All right. So the yacht shown in figure 1 has a mass of 8,300 kg. Determine its weight in air. Okay, guys. So we are given mass, and they want us to find for what? What do they want us to find for, Yvonne?
The weight.
What formula has weight and mass in it? You had to know these things, eh? Weight is equal to what?
Mass by gravity.
Right. W is equal to m by g. The mass is 8,300. And what is the gravitational constant?
10 newtons kilograms.
Right? Gonna multiply that, and they're gonna end up with 83000. What's the unit for weight?
Kg.
Kg.
I mean newtons.
Newtons, right? Because weight is an example of a force. Right. Read part B for me.
For land transport, the yacht is secured on a trailer. Each tire on the trailer can support up to a maximum of 7,000 newtons. What is the least number of tires the trailer should have to support the yacht adequately?
All right. Before we do anything, um, the yacht is over here, and the yacht is. Would you say that the yacht is exerting an upwards force, or is it exerting a downwards force?
A downward force?
Downward force, right? So wouldn't the tires have to exert an upwards force with the same amount of force?
Yes, sir.
Yeah. So this is 83,000 downwards, and they are saying here that one one tire could hold up to a maximum of 7,000 newtons. So how do you think we'd figure out how much tires they would need? Do you have any ideas? Come on, you are. Yvonne,
Yes, sir.
you have any ideas?
No, sir.
Okay, Yvonne, what is the weight of the boat?
83,000 newtons.
Right. So if I want to hold up the boat, I need to be exerting an upwards force of at least what?
83,000.
How much could each tire exert?
7,000.
I think you could see it. Try to figure it out.
Yeah.
Keep your mic unmuted. I want to hear the process. Right? Keep your mic unmuted. I want to hear your thought process. So unmute
Oh, you had to divide 83,000 by 7,000.
correct. So number of tires. So the number of tires would just be 83,000 over 7,000. What would that be?
11.85.
Can you get 0.85 of a tire?
Nah, so you gotta run it off. It's around 12 tires.
Yes. All right. Jadon, you there?
Morning, sir.
Morning, morning. So did you get a chance to do the homework?
No, I didn't get a chance to do it this week. Sorry.
All right, well, we just running through it, right? So in
Yeah.
this first question, they gave us mass of a yacht, and they wanted us to figure out its weight. Weight is
hmm
equal to mass times gravity. The mass is 8,300. The gravitational constant is 10. So 8,300 by 10, 83,000 newtons. So the
hmm
yacht is exerting a downwards force of 83,000 newtons. So I'm saying if you want to hold up that yacht, then the tires would need to exert upward forces. And when you add up the upward forces, it needs to be at least 83,000 to keep the yacht up. Remember, downward forces is equal to upward forces.
Yeah.
Yeah, so all of these tires will be exerting an upwards force, right? And in the second question, they said that each tire, right, could support up to 7,000 newtons. So if I want to figure out the number of tires I would need, I would put the amount of weight it has to hold up divided by the amount of weight one could take. That makes sense?
Yeah, yes, sir.
And Yvonne, you had got 11 point what?
11.85.
But Jadon, can you have 11.85 of a tire? Can you have 0.85 of a tire?
No,
No. So you got to round that to one. So how much tires it will be approximately?
12. 12 tires.
Right, 12. Great. So Shayna, is what you have correct so far? I'm gonna check what you have.
Yes, sir.
Wait, I see in that hmm. For the first one, I see you have W. I cannot confuse about the first weights.
Wait,
No,
equal
it's all over.
concept.
Okay, I see where you start now. Yeah, you multiply by 10. Right, you add
Also,
2,000.
I think I sent the question within class by accident to the 2022.
Ah,
So go to the thing after.
okay, yeah, I see it, I see it. Nice. Yes, so far you're good. So you understand that, right? Jira, help me with part C. So many forces. We didn't hear in Jira. Jira, read part one. Okay, I see Jira on mute. Yeah, Jira, tell me, come true.
Um, Two conditions that we're answering part C, right? The first part,
Yeah,
correct? Um, all upward forces are equal to all the downward forces.
right. So sum of upward forces must be equal to sum of downward forces. So you could say that, or you could say net upward forces is equal to net. Yeah, right. What's the second condition, Jida? For a system to be in equilibrium,
Um, all the clockwise something
right? Sum of anticlockwise moments
are
is
equal
equal,
to the sum of clockwise moments.
right. If you said sum of clockwise moments is equal to sum of anticlockwise moments, that's correct as well. So, Jiran, if you said this, it'll be correct. If you said the other way around, it'd be correct. If you said clockwise is equal to anticlockwise, fine, that's correct.
Okay.
Same thing,
Mhm.
right? So, Jira, part two now. State the effect that the position of the center of gravity of an object has on its stability. So, think of a skyscraper versus a flat house. Which one more stable?
A flat house.
Yeah, flat house, and that's because its height is less. Let's look at what that means. Wouldn't the center of gravity for this one be like over here versus this one quite over here?
Yes.
So, okay. So, how would I answer this question then? So, what are you observing there?
That the lower that the center of gravity is, the more stable the object is.
Right. The lower the center, the greater its stability. Right. State Archimedes' principle. All right, Sheena, what is Archimedes' principle?
The upward force exerted on an object immersed in a fluid is equal to the weight of fluid displaced.
right? So the upward force exerted on an object immersed in a fluid is equal to the weight of fluid. And that's what I said. Just verify.
Yes, sir.
Right? So the upward force exerted on an object immersed in a fluid is equal to the weight of fluid displaced. So Jadon, let me explain what I mean by that. So Jadon, if you put, let me just say you put a piece of wood in water, right?
Yeah.
Yeah. And obviously the wood would experience a slight push upward force from the water.
Yeah.
Yeah. Now, if I put this in a cup or something, wouldn't the volume rise? Yeah or no? If you put something in a cup, wouldn't the water level rise?
Yeah. It would rise.
The reason for that is because that object is now adding volume to the water or whatever it was. So it's
Hmm.
gonna displace some, it's gonna displace fluid, right?
Yeah.
And the amount of fluid it's gonna displace, right? That weight is equal to the upward force felt by the object. So, by you putting an object in this cup, a certain amount of water is going to be displaced, and the weight of that water is actually equal to the force felt by the object. Understand? Or you want me to explain
Yes.
that one
So
more time?
you could go on it. Yeah.
Okay, I'll go into it. No problem, no problem, no worries. Like I put a piece of block here in a cup, right? See that?
Yeah. Yeah.
Now let me just draw this thing without this in it. 1 second. So before I put in that block, would the volume be greater or lesser?
Lesser.
Right? It will be lesser. So by me adding in a block of wood, wouldn't that displace some water?
Yeah. It would.
It would, right? So wouldn't this be the amount of water displaced? Watch.
Yeah. Okay.
Right. Now we understand that because of liquids having a density, by you putting something inside, it would naturally have a buoyant force. It would push up slightly. And you would feel this when you're going to the beach, right? When you're going to the beach and you could do a push up in the water.
Yeah.
You could do plenty things in the sea that you can't do normally on air, right? And the reason for that is because water, if you're in a fluid, right, it naturally exerts an upward force. So it kind of gives the illusion that things are lighter. Understand? So,
Yeah. I
so do
understand.
we so do we understand that because the block is in water, it's gonna have an upward force on it. It's gonna feel a little push.
Yeah. Yes, sir.
Great. Now, wouldn't that correspond to a force?
Yeah.
So we are saying that this force, this upward force, that would be equal to you see this over here? You see how we talk about this? You see how we talk about the fluid displaced? Like by you putting that block inside, any water level rise, and that's because you displace a certain amount of water, right?
Yes, sir.
Right? So the upward force would just be equal to the weight of, in this case, water displaced. I don't know if you understand that.
Yes, sir.
So, run back one more time. You put a block in a piece. You put a block in a cup of water, right? The block is gonna feel an upward force on it, a small upward force. We are saying that that upward force it feels is actually equal to the weight of water displaced, right? So this is the amount of water that was displaced. So if you could find the weight for that, you could figure out the upward force on the block. So that's the concept of Archimedes' principle. Nice, right? So Shayna, let me handle part two. I think you left out part two. Was it part two or part three? You leave out part two?
Patrick.
Part three? Okay, well, let me do part two, right? So the yacht's hull is made of steel with density rho s. By the way, this symbol means rowboat, equal to 7,850 kg per meter cube. Right? So for every meter cube, it would have a mass of 7,850 kg. Explain how the yacht is able to float in seawater of density 1,025 kg per meter cube. Right. So Shayna, this is clearly an anomaly because for something to float, wouldn't the density of the object need to be less than the density of the medium?
Yes,
So why is it still floating?
because the hull is have a hollow interior, and the hollow design makes the overall density decrease.
Perfect. Right? So the hull of the yacht is hollow as such majority of the majority is this decreases the overall density such that the combined density is less than. Right. So the hull of the yacht is hollow. As such, majority of the hull is steel plus air. This decreases the overall density such that the combined density is less than the density of water. Right. So Jada, do you understand that if you put something with a greater density, like let me just say you put a metal block in a cup of water, will that float? Tell me, Jada, if you put a solid metal block in a cup of water, will that float? Okay, Yvonne, take the question from Jada. So Yvonne, if I put a solid metal block in a cup of water, will it float?
No, sir.
What if the outside of the block was metal and the inside was hollow? Would it float?
Yes, sir.
Yeah. Now, if you have a solid block, right? If you have a solid block of metal, wouldn't the density be very big?
Yeah.
Okay. And the reason for that, do you remember the formula for density? This formula for density.
Density is mass over volume.
Mass over volume, right? If the mass, question, if the mass increases, what happens to the density?
It can get higher.
It get higher. If the mass is less, what gonna happen to the density?
It can get lower.
Okay, so if I have a solid metal block, that mass gonna be real mass, right?
Yeah.
But if I have a hollow metal block, do you think the mass would be much less?
Plenty less.
Plenty less. And that would drop the density because the mass would go down. So it make perfect sense, right?
Yes, sir.
Okay, great. Jaden, you understand what I'm saying?
Yes, sir.
Okay, great. So you understand by the outside of the hull being metal and the inside being air, that dramatically decreases the mass. And if that cuts down the mass by a lot, then the density is going to be decreased.
Yeah.
So that the total density will actually be less than water, right?
Yes, sir.
You understand? For something to float, the density of the object needs to be less than the density of the medium it's placed in.
Yes, sir.
Okay, great. Calculate the volume of seawater displaced by the yacht as it floats. So Shayna, let's tackle this question. So Shayna, according to Archimedes' principle, what does it say? Just remind me. What does Archimedes' principle say? You have to use
That
Archimedes' principle
the,
first.
that the weight of an object is equal to the weight of the liquid displaced.
Right. Weight of object is equal to
Weight of the object displaced. The weight of liquid displaced.
weight. I was really looking for weight of object is equal to upward force. A way to read back your definition from Archimedes' principle.
Yes, sir.
Read back what you said for Archimedes' principle.
The upward force exerted on an object immersed in a fluid is equal to the weight of the fluid displaced.
Right. So wait, it says that, read back one more time.
The upward force exerted on an object immersed in a fluid is equal to the weight of the fluid displaced.
Right. So wait, I'm making a mistake here. Yeah. So it should be weight of fluid displaced is equal to the upward force. Right, Jaden, remember we was talking about that? Weight of fluid displaced. Jaden, you remember talking about that? With this example, I said
Yeah.
that the upward force is equal to the weight of water displaced. This is essentially what we're looking at here. So the upward force is equal to the weight of, well, in this case, we're going to generalize it and say fluid inside of water, right? Because NT could be any liquid,
Yes, sir.
gotta be water. Right, so Sheena, you okay with this part, right?
Yes, sir.
Yeah, sure.
Yes, sir.
So you understand when you put a yacht in the ocean, the water level is gonna rise like ever so slightly, but it will rise.
Yes, sir.
Yeah. So the yacht is actually displacing water, right?
Yes, sir.
Great. So I'm gonna show you how we're gonna do this, right? So just a couple of formulas you need to know. Density is equal to what?
Mass over volume.
Rate. So question, do we know the density of water?
Of the seawater. Yes, sir.
What's the density?
It was um a 1,025.
Okay, so we know the density, right? Great. We know the density. Do we know the mass?
Yes, sir.
Yeah, what's the mass?
8,030. I mean 8,300.
What are we trying to find for?
The volume of the seawater.
Yeah, the volume of the seawater, right? So You probably wouldn't need Archimedes principle. I'll try to find out with the tiothene after we're done, but you don't need it. This is suitable enough, right? So Jadon, let me run through the question one more time. The question is asking us to calculate what, Jadon? What is it? What is the question? What is the question asking of us?
The volume of the seawater displaced by the
So
yacht.
they want me to find for the volume of the seawater displaced, right? Wouldn't the volume of seawater displaced be caused by you putting the yacht in the ocean?
Yeah, yes, sir.
And doesn't the yacht have a mass?
Yes, it does.
Right. So, and do we know the density of the seawater?
Um, yes, they gave it.
So do we have all the pieces of the puzzle to find for volume?
Yeah,
Yeah, we
massive amount.
right.
The 83,000
Right. 8,300 kg. Let me run that back one more time. Newtons is weight. Mass is kg. And they
Okay,
told us at the start it was 8,300 kg. So let me show you how we're going to do this, right? So the density, let me just rewrite this formula. So density of water is equal to m all over v, right? I, you want to write the formula specific to the question. If you notice in this question, they're using rho w to signify density of water. So I just put that in, right? So now I'm going to substitute what I have. My density of water is 1,025. What is my mass?
your mass is the 83 of 8,300.
Right? And Shayna, do we know the volume?
No, sir.
Nah. So what we had to make the subject of the formula there? Who we had to make the subject?
Volume.
The
Volume,
volume,
right? Let's make volume. Right. Look at where volume is. Right now, volume is in the denominator. What I have to multiply by on both sides to get rid of v from the denominator. Jaden, see if you can figure that out. Right now, I have divided by v. What do you think I should do to get rid of v from the denominator?
divided by V on the other side.
Nah,
No,
I should multiply by v.
multiply.
Let me show you why I'm
Sense.
saying that, right? If I multiply by v on both sides, let's look at the full working. That 1,025 is going to turn to what, Jadon? That's going to turn to 1,025 what?
Um, minus. No,
No,
not minus, negative, sorry.
no, not negative. We are multiplying by v on both sides.
Mm-hmm.
Let me give a simple example, right? If mm, if I tell you, if I say this is one PS5 and I multiply that by 5, how much PS5s I have?
PS5s,
5 PS5s, right? If I have 1,025 and I multiply by v, how much?
1,025.
Yeah, yeah. So that's gonna be 1,025 v, and on the other side, it's gonna be 8,300 all over v multiply by v. What's gonna happen there?
The V's are going to cancel out.
Yes. Do you understand why I multiply both sides by v now?
Yeah,
Right? Because it got rid of it from the denominator and it allowed me to get it in the numerator now on the other side. So I end up with 1,025 v equals to 8,300. What's the last step? I want to find for 1v. I want to find for v. So what I should do to get rid of that 1,025 by the v?
you carry across the 1,025.
Right. You could think of it like that if you want. So this 1,025 is being multiplied by v. So if I carry it across, it's gonna turn to what? So right now I'm
V equals to 8,300 divided by 1,025.
perfect. Right? What you said was perfectly fine. I just prefer to write it like this, but what you're saying is completely correct, right? I like to divide both sides by 1,025. And what would you get for your answer?
I got 8.097.
8.097. That would be 8.10. if you round it off to two decimal places, which is what we typically do. You understand how I do that?
Yes, sir.
Shina, what do you think about the question? Easy or hard?
Easy, sir.
Yeah, yeah. So, here what? Anytime you're confused, just most of the time, and you know you're doing volume, and you know you're dealing with density in this whole question,
Yes, sir.
write down the density formula and see what information you have. Right? Because you see, as soon as you write down rho is equal to m over v, you see you have rho, you see you have mass. What's the only thing you don't have?
Volume.
You see how easy it was as soon as you write down the formula? That's a hint I'll give you. Anytime you're doing a certain question in physics, write down the main formula, look for the key information you have, and look and try to see where you're missing. If you're missing one thing, you could find for that one thing. So in this case, we was missing volume, so we could have find for volume. Right? And we get 8.10. Right. And the what would be the units of volume here? Let's look at the density. It'll be meter cube. Right? 8.10 meter cube. Shane, are you okay with this question?
Yes, sir.
All right. Nice. I wonder if we could do a harder question, boy. Let's see. So, Shina, what if they had asked you to figure out the upward force felt by the boat or by the yacht? You think you would have been able to handle that? Be honest with me. Would I be able to handle that?
Is the alpha the upward force?
Yeah, if they ask you for the upward force felt by the yacht. I'm just adding that new question. So Sheena, read that question for me.
What is the upward force felt by the yacht as a result of it being immersed in the sea?
What that reeking of? That reeking of what? What does that reek of? What principle?
Archimedes.
Yeah, I just remember what Archimedes principle says.
That the weight of the fluid displaced is equal to the upward force.
Right, weights of. Great. So here it is, right? We need to figure out what weight of fluid was displaced. Yeah?
Yes, sir.
Okay. You think we could figure that out?
Yes, sir.
Okay. It's actually extremely simple, eh? Like this question actually extremely simple. But we'll I'll do the long way first and you go see, right? So, Shina, do we know the volume of seawater displaced?
Yes, sir. 8.10.
Right. 8.10. Let's use the exact value, right? Actually, I'll use 8.10 to simplify it for now. So we know that the volume is 8.10. If I have volume, is it possible for me to find for mass? And then, and if I have mass, I can find for weight? Tell me,
Yes, sir.
yeah. So I have volume, 8.10 meter cube. Is there any formula I could think of that contains volume and mass? Volume and
So
mass.
mass over volume.
Yes. Rho is equal to mass all over volume. Again, we're in seawater, right? And we know that the density for seawater, that was given to us earlier, right? It said it was 1025, right? So 1025 is equal, we don't know what the mass is, all over 8.10. Now, if I were to use the exact value, right, the exact value would really be 8300 over 1025. It would be 8300 all over 1025. That's the exact value for the volume, right? So for me to find for M, I would need to multiply by what on both sides. Tell me, Jaden. Jaden, if I want to find for M, I promise you, it's the same concept like this. I wanted to find for V, so I multiply by V on both sides, so that cancel off. So what do you think
Yeah.
I should multiply by on this? Multiply by on both sides. Tell me.
Just same M.
Wait, I want to find for M.
Oh, so define it. You wanna so, um
So right now, M has something underneath of it. So what would I need to multiply by to cancel off what is underneath? What is the
the 8,300 over 1,025.
perfect? So if I do that, it's gonna cancel off on your right hand side end, and it would cancel off.
Yes, it would.
Okay, and on the left hand side, that will be 1025 multiplied by 8300 all over 1025 is equal to M. So M is just equal to 8300. Shina, you see why at the start I told you it would have been extremely simple. I think you could see why I say that.
Yes, sir.
So essentially, right? If you put in the boat or the yacht in the ocean, wouldn't you be wouldn't and we calculated at the very start, we calculated the downwards force. And we
Yes, sir.
yeah. So wouldn't the upward force be 83,000 newtons?
Yes, sir.
Yeah, yeah. This was a trick question because you could answer it from the start. So M is equal to 8,300 kg, right? And as such, the force would just be that 8,300 multiplied by 10, because we know weight is equal to mass times gravity. And you should also know that force is equal to mass times acceleration. It's the same formula, right? And A was 10 in this case. So 8,300 by 10, and you're just going to get back the same answer from the start. That's 83,000 newtons. Yeah. So this is a trick question. At the start of it, you could adjust the 83,000, right? Cool. I want to do some more work on Archimedes principle, so I will get some more questions. Jaden, do you feel like you need some more practice with Archimedes principle?
I feel it's just like doing over some questions by myself, really.
Okay.
I don't, yeah, I understand it when you explained it, so I'll just go over some of my questions by myself.
Okay, no problem. Give me a second. I'm gonna get some questions. Right. So before I move on, I just want to discuss the principle of flotation. Right. Shina, would you prefer me to start with the new note on the next page or on the same page?
Next page.
Next page. Okay, great. So what does it mean for an object to float? Let me show you what I'm talking about. So Jada, if something is floating, that suggests that the downward forces is equal to the. Can I hear from Jada? Could somebody tell me if I'm saying that something is floating, it kind of suggests that the downward forces is equal to the what forces?
Upward forces.
Upward forces, right, Jada? You understand that?
Yes, sir.
So Jada, let's look at the previous question, right? When I put this yacht in the ocean, will it float?
Yes.
Right. So if it floats, that means that the downward forces must be equal to the.
Upward forces.
So let me show you something, right? What's the downward force on this boat?
83,000 newtons.
When we did the long calculation, which we didn't have to, what did we get for the upward force?
83,000 newtons.
And it makes sense, right? Because what is the yacht doing in the ocean?
Floating.
Exactly. But there's more cases you need to know,
Mhm.
right? So this is case one. This is when something actually floating, right? Give me a second. Try to make my diagrams a little fancy. Okay, fancy thing. I'm gonna put a block here, right? Okay, everybody, right? Can we agree that that block there is floating? Yes or no? Wait, give me 1 second. Can we agree that that block is floating?
Yes, sir.
We could, right? We could agree that it's floating. Now, for something to float, what we know about it?
It would be hollow on the inside.
Okay, what you're saying is right, but
No, you're
that's
looking
not what
for.
I'm looking for.
Um,
The
um,
upward force is equal to the downward force.
Right, right? So this is clearly floating. So in this case, the upward forces right? So if I were to draw the the forces that are acting on this, right? I'm gonna do that. So can we all agree that because it's in a liquid, it will have an upward force? Yeah or no?
Yes, sir.
Right? And the specific name for this is called the buoyant force, right? If you didn't know, now you know. So that's the buoyant force there. I can call it FB, right? Right? And what would be the downward force of that object? Does anybody know?
The weight.
The weight, right? Jaden, does that make sense?
yes, sir.
Great. So the weight, which is equal to mg. And we know that weight is equal to mass times gravity. Yeah or no?
Yes, sir.
Okay. So if I were to write the equation for this, I would say that the upward force, which is the buoyant force, would be equal to mass times gravity, which is the weight. And we saw that with the question we just did, the extra question I added in, because Jadon, any yacht was floating.
Yes, it was.
So if it was floating, right, wouldn't the downward force be okay? So the downward force here was 83,000 newtons, right? And that was obviously, how did I find that? Didn't I found that by mass by gravity? So that's the weight?
Yes.
Yes. And this is the weight of the yacht?
Yes, it is.
Right. And because it's floating in the sea, then this condition must be met. So the upward force must be equal to the downward force. So if we know the weight, if we know that the weight is 83,000 newtons and the upward force ought to be 83,000 newtons as well,
Yes, it should be.
because it's floating, right? That makes
Mhm.
perfect sense. Great. So copy this down. Right? And if you want to be very specific, this floating, let me just write this in red, then I write it in black. So this first case refers to, right? And this is referred to as neutral equilibrium. Now, guys, you could technically call the upward force anything, right? Would you all prefer me to write FB or U? Either one is fine. But what would you prefer me to use going forward? U or FB?
FB.
FB?
Yes, sir.
What would the rest of you guys like for upward force? Would you prefer FB?
FB, in my opinion.
Okay, cool. Does everybody understand that the upward force is also called the upthrust? Or no, you don't know that?
Yes, sir.
Okay, I'll make a note about that. So if you're reading a textbook or something, yeah, you wouldn't get confused. Right? So, Jadon, sometimes you'll see the question asking you for the upthrust. I need you to know that upthrust is the same thing as upward force. Upthrust means upward force.
Okay.
So if they ask you for the upthrust on the object, they're asking you to find the upward force. Right, so that's the first case you need to know. Let's look at the second case now. Right, the second case. Okay, what's the opposite of floating, guys?
Thinking.
Sinking. Right. Now, if something is sinking, so just copy this diagram. Now, Jadon, and for something to float, the upward force, which is the buoyant force, needs to be equal to the downward force.
Yes.
So if something's sinking, do you think the buoyant force is enough to keep it afloat?
No.
No. So you'll see what my diagram is going to look like. Right? Check this. Right? That's weird. Okay, that's fine. I'll just draw it back. All right. All right. So tell me, Sheena, from the diagram, can you see that it's clearly sinking?
Yes, sir.
It's sinking, right? Now, if it's sinking, is the upward force enough to counteract the downward force?
No, sir.
Nah. So, as always, the downward force is going to be weight, right? Weight is equals to mass times gravity. Shina, is weight a capital W or common W?
Capital.
Right, capital W. Nice. So weight is equal to mass times gravity, and the buoyant force for this is going to be less. So with this condition, the buoyant force is going to be what? What do you all think? So this one was equal. What do you all think I'm going to write here? Tell me, Yvonne. In this case, it was equal. What do you think I'm going to write here? Equal to, more than, less than? What do you
Less
think?
than.
Right? So the buoyant force would be less than the weight of the object. So if that's the case, it wouldn't be able to keep it floating. Right, Jadon? Do you understand what I'm saying?
Yes, sir.
Okay, so Jadon, there's a third case, right? Do you think you could figure out what the third case is? So we have floating, sinking, and the other one starts with R.
Um,
Okay, yeah, and think of a submarine coming back up to the surface.
Ryzen.
Rising, yes. Right. Anybody here know about digital rising stuff?
That was POP, sir.
Yeah, you know about that? And it had this be mobile one.
That, yeah, that was pure. That was good.
That was real kicks.
I used to sit down and watch out my grandma.
Them is the days, yes. All right. So I'm trying to figure out how I could show that it's sinking. Wait, let me just I guess I could do that to show it's sinking. All right. And with this one, I could show it like trying to figure out how I could draw this one. Yeah. Um, Shayna, if I put it over here and I draw some arrows to the side going up, would you understand it rising?
Yes, sir.
Yeah, sure.
Yes, sir.
Okay. Yvonne, what about you? If I like draw that there and I put arrows showing like it going up, you gonna understand that?
Yes, sir.
Okay, let me also add in an additional element. This is to show that after some time it go rise. I did one in it. Yeah, this thing real frustrating. This new update. Horrible. All right. Great, great. All right. Jadon, if something is rising, what does that say about the forces?
The upward force would be greater than the downward force.
Perfect, because it's rising, right? The upward force would dominate the downward forces. It would push it upwards.
Yeah.
Great. So these are the three cases you need to know. Let me get one more Archimedes principle question, and then we're gonna move on. All right, so if this is the case, the buoyant force, which is the upthrust or the upward force, would be more than the weight of the object. Great. So these are the three cases you need to know. And generally speaking, for something to float, let me just write down something as well. You gotta know this. If an object is less dense, right? Right? So if an object is less dense than the medium it is placed in, it will what? Could somebody tell me? If I put an object that is less dense in a medium, if I take an object and I place it in a medium, right? And it's less dense than the medium, what happen? Tell me, Jaden, what happen? It go sink or it go float?
It'll, it'll float. No,
It will
it's
float.
less.
Here what the sentence saying, right? If an object is less dense, so less dense than the medium it is placed in, which what that means is whatever you're putting it in, denser. So that come like putting a hollow block of metal, right? In a cup of water. Understand?
Yes.
You sure you understand that?
Yeah. So you can give me a second at home.
Okay, no problem. So copy that down. Let me just get one more tricky question. All right, so as soon as you have that copy down, let me know, right? Shayna, do you have that copy down?
Almost.
Okay, good. Yvonne, what about you? I expect some spectacular drawings.
I freehand and everything.
Okay, well, even better. I expect some exemplary free-handed drawings. It should be better than if you use a ruler. Yeah.
For sure.
I'll say when you finish, you can just go back on the rising symbol.
Okay, sure, no problem. All right, so does everybody have that copy down?
Yes, sir.
Yeah, Yvonne, Shina, Jada, you
Yes,
guys
sir,
have
I
it?
got
Okay, good. Shina, you good? Shina? Can I hear from Shina? Okay, Shina Wi-Fi is good trouble. So here what? I want you all to try this question, attempt it. I'm giving you all 5 minutes. Go. All right, Shayna, are you there? Shayna? Can I hear you, Shayna? Yvonne, again, through the question
Kinda, sir.
right now. Did you get through it? Part A.
Yeah.
How about B?
I'm working on that right now, sir.
Okay. Okay, I think you'll need some more time. Where did you all reach? All right,
I'm on B.
you on B? You getting through B?
Yeah. So,
All right, Jalen, tell me what formula you had to use for B.
um, when they say calculate the upstress of the leavings and all, listen, the mass equals to, is it with rho by volume?
Mass is equal to rho by volume. Yeah, yeah, that's correct.
Oh, well, P equals, rho equals mass by volume. Sorry. I was watching that.
Yeah. So I'll give you all 3 more minutes. All right, I see, Shayna, I see you back inside. Let me know if you're okay.
Just so I got disconnected, but I read another question now, can try.
Okay. This is the trickiest question yet. And it combines everything we learned thus far. So as soon as you all are finished, let me know. D might give you some trouble. All right, guys. Does any of you all have an answer for A, B, and C? Are you one? Let me see what you try here. Are you one? Ah, we have work to do. Are you one?
Yes, sir.
Yeah, we have a good bit of work to do.
Alright.
Yeah. Right? Jalen, did you get through with A, and B, A, B, and C?
Yeah. So,
Some way you have so far. Right?
okay.
So Yvonne, let's start answering the question. So Yvonne, give the question, all right, please.
Okay. A solid metal has a volume of 1000 centimeter cubed and a mass of 7.8 kilograms. It is carefully lowered into a container of water. A. Calculate the weight of the cube in newtons.
Okay. What do they want us to do in part A?
And calculate the weight.
Okay. What's the formula for weight?
Mass by gravity,
What's the mass?
7.8 kilograms.
And what is gravitational constant? G.
10. 10 Newton kilograms.
When you're doing calculations, you don't have to put the units. Right?
Okay.
It's 7.8 by 10.
Yeah. That is 78 newtons.
If you didn't have this, tell me now.
I got that too.
Nice.
I realize I sent that picture sideways, sorry.
Okay. I like what you have there, right? Most of what you have is correct, if not everything. You just
I,
better ways
s-
you just have
yeah,
better ways we could write it. But excellent job.
I just stuck on D, and I was swimming by spring balance, but when I get to that,
All right. So basically, they just, you remember how I told you, if you're in the sea, right, and you could lift up somebody, you could do push-ups and all kind of thing.
yeah,
Yeah.
The reason for that is because when you're in the sea, doesn't the water, the salt water, um, exert a upward force on whatever that's inside? Think about it. If you're, and you can float on salt water, and you can float in the sea, yeah.
Yeah.
yeah,
Why could you float on the sea? That's because of the upthrust. So anytime you're immersed in a fluid, there will be an upwards, there will be an upthrust on you because of the fluid. So, Jadon, do you
that's
think
it.
and when you're in the sea, right, you could lift, like I said, you could lift up somebody underwater, right?
Yeah,
But you can't do that on land. The reason for that is because they would weigh more on land. If they're in the sea, the upward, the upward, well, the upthrust or the buoyant force would help you, right? Because and we know that if you have something submerged in a fluid, wouldn't there be an upward force acting on the object?
yes,
Am I confusing you?
no,
Think of
that's
an
not
ice
true.
cube. Think of an ice cube, right? And if an ice cube in water, the ice cube would float.
Yeah,
That's because the water exerts an upward force on the ice cube. So if you're in a fluid, because you're in the fluid, there will be an upward force on you. So tell me, Jiran, if you have a if you're in the ocean, right, and you have an upward force on you, would you still weigh the same as if you was on land?
no,
No. Would you weigh less or more?
that's,
You would weigh less. So if the mass, okay, wait, if the weight is 78 newtons, right?
mhm.
And what's the upthrust? Remember, what's the upthrust?
The up thrust is 10.
Upthrust is 10. So if you were to lift up if you were to lift up this object and it was submerged in water, what would be the weight you would feel?
The, the 10,
No,
the drop,
the 10 newtons is the force, is the upward force that would be exerted on this cube.
mm-hmm.
So watch. You have a cube here. The upward force would be it would be 10 newtons, and the downward force would be 78 newtons. So what would be the force that you actually feel?
78 newtons.
No. It come like again assistance from the water. That's my hint. How much assistance are you getting from the water?
Hmm. Oh, the how they said in the where there was like P, well not P group, but is it 10 ms? That's the assistance, the 1,000 kilograms.
No,
That's the
that's the density of the water. Okay, so Jadon, if something is submerged in a fluid, the object will experience an upthrust. What does an upthrust mean, Jadon? What does an upthrust mean?
it means the like the upward force.
Okay, right? So because the metal cube is being submerged in water, what force is already pushing it upwards?
The 10.
Right. So that's the force, that's the upward force, right? And what's the weight of the object?
7.8
No, seven,
kilograms.
no, 7.8 kilograms is the mass. That's not
Mass.
weight. Weight is the 78 newtons.
Mhm.
So if it has a weight of 78 newtons, and because it's in water, the water pushing it up with 10 newtons, how much would you feel when you lift it up? Try to piece it together.
Would it be 78 minus 10?
Yes. Because you
So
know, because it's in water, right? And the water already pushing it up with 10 newtons.
yeah.
So how much you want to add to that? Lift it up.
Would add or subtract?
Add. If the water is already lifting it up with a force of 10
10
newtons,
newtons.
you
Mhm.
would just have to lift it up with a force of 68 newtons. Okay,
Yeah.
I feel like I'm confusing you.
No, no, no.
If
In,
you had to lift up something, right? If you
yeah.
wanted to if you want to take it up, if you want it to be at equilibrium, the downward forces must be equal to the
Upward forces.
correct. So because of it being submerged, what force is being felt by it? Like what upward forces does it have? Just by being submerged. What's the upward force?
10
10?
newtons.
Right. So just by that metal cube being in water, it's feeling an upwards force of 10 newtons.
Yeah.
Now, if I want to fully lift it up, I need to apply an upward force of
68 newtons.
no 78.
Well, 78.
Right. But out of that 78, how much is already how
Being
much
lifted.
force is already feeling? 10, right?
Yeah.
Let me run that back one more time. If you want to fully lift that up, you have to apply an upward force of 78 newtons to counteract the weight, right? Yeah.
Yeah. Yeah.
Out of that 78 newtons, what upward force is already there?
The 10.
The 10, because it's submerged, right?
Yes.
So if you have to lift this thing up, how much force would you have to apply again to fully counteract the weight?
78 newtons.
No.
Six,
It already has an upward force at 10. So you just had to add on 68 more.
68.
Yeah. The answer is 68. A spring
But
balance is just used to measure the force, right? So if you use a spring balance to support the cube while it's fully submerged, it will have a reading of 68 newtons because the cube is already experiencing an upward force at 10 newtons. So for you to keep this thing at equilibrium, you would need to apply 68 newtons to counteract the 78. You see, it already have 10 newtons.
yeah.
So you just had to apply 68 newtons again to keep it at equilibrium. You understand?
Okay.
You're sure you understand that? If you're confused, tell me.
I understand.
Okay. Right, so you've won. Let me do B, right? What do they want us to do in B?
To calculate the upthrust.
All right. What formula I should write down one time? We know we're dealing with density and thing. What formula you think I should write down? In case you're confused, watch this. They are
Okay, wait.
telling you what the density is. What formula should come to mind anytime you see they give you density?
Um, volume.
Nah. What is density equal to? What is
Density equals to the downward force and the
no?
upward.
Yvonne, you had to real do work on your formulas, eh? You had to do some serious work memorizing them formulas. Density is equal to mass over
Gravity.
no volume.
Oh, volume.
Yeah, you had to work on them formulas. Density is equal to mass over volume, right? And they want us to figure out the upthrust. Let me show you how this is going to work, right? Upthrust is an example of a what? Starts with F.
A force.
Right. So they want us to find a force. Right. So Yvonne, is
Yeah.
there any element in this formula that if I find, I could find for force? Does it have anything in that formula I could potentially use to find for force?
The mass.
Yeah. So once I find for the mass, I could then find for the force. My next question. Do we have density?
Yeah.
What's density?
Is 1,000 kilograms per meter cube.
Right? I'm gonna be in 1,000. Do we know what the mass is?
No.
Now, do we know the volume?
Yes, sir.
Yeah, no, no. This is a place where real students will get confused. Why shouldn't I put 7.8 over here? Probably wondering that because it says mass over volume. Yeah.
Yeah.
All right. We are trying to figure out the upthrust. Do you know if this is floating or sinking or rising?
It rising.
You sure about that? Do we know that for sure?
I don't know.
No, we don't know that for sure. So we can't assume anything. We can't assume anything for now. So I'm using rho is equal to mass over volume. Remember, rho is the density of water, right? V is the volume of the metal cube. So what I'm really trying to find for there is I'm trying to find the mass of water displaced. And then I could figure out the weight of water displaced. So, Yvonne, you see this formula here? This,
Yes.
I'm using this formula to figure out the mass of water displaced. I'm not putting in the mass of the object. Do you agree that not all the time, let's look at these cases, right? And this is the only case where the upward force is equal to the weight.
Yes, sir.
If you look at all these other cases, they're not equal, right?
Yeah.
In this example that we did, the upward force just happened to be equal to the downward force because it was floating. But you cannot assume that over here. They didn't mention anything about floating. They said it was lowered into a container. So most likely it's sinking. But we go see. Right, so you find how to use density is equal to mass over volume. And let me just make a note here. When you use this formula, what you're really finding for, you're really finding for the mass of water. Right. And tell me, Yvonne, if I have the mass of water displaced, what I could find for next? If I have the mass of water displaced, what I could find for next?
Volume.
No. If I have mass, I can find for force.
Oh yeah.
Mm-hmm. Right. And this is Archimedes' principle. Remember, Archimedes' principle, do you remember what Archimedes' principle says?
Yes, sir.
Tell me what Archimedes' principle is say.
The upward force that is exerted on an object immersed in a fluid is equal to the weight of the fluid displaced.
Perfect. So when we use this formula, we are finding for the mass of water displaced, which we are then going to use to find for the weight of water displaced. And the weight of water displaced is equal to what? What force?
The updraft.
Exactly. Exactly. So everything connecting. So
Yes, sir.
now there's a bit of a problem. They give us a volume in centimeter cube. Can I work with centimeters?
No, sir.
No, we had to convert that to meter cube. So let me do that. So they gave
You're
me
gonna
the volume
divide
as
by a
one.
million.
Say that again?
Yeah, divide by a million.
Yeah, you had to divide by a million. And I'm not gonna write a million. I'm gonna write 10 to the power 6, which means a million. Right? And that would give me meter cube. When you work that out again,
0.001.
0.001, right? So that's what the volume is in meter cube. So I'm going to substitute that over here. 0.001. Okay, from here, if I want to find for M, what do I need to do next? Let's put this over here. Tell me you want. From here, what would I need to do to find for M? Right now,
You're gonna
M
have
is,
to multiply.
say that again.
Multiply
Multiply both sides by what?
by 1000.
Mm. Well, it technically could actually, no, I wouldn't recommend it. So, Yvonne, we have M over 0.01, right? I want to find for M. Right now, M is being divided by 0.001. Or what I need to do to get rid of the 0.001. The only thing I want here is M. Tell me, Yvonne. I want to multiply by something so that I would cancel off for that. So what should I multiply by on both sides?
0.001.
Right? If I do that, it will cancel off here, and I would leave me with M. M is equal to 1,000 multiplied by 0.001. And what would I get?
You get 1.
1 what?
1 kilogram.
1 kilogram. Right. So that represents the what? What does that represent?
The mass.
Mass of what?
The mass of the obtuse.
You can't say mass of the obtrus because obtruses are force. The mass of the
Water displaced.
right. Using that, we could figure out the weight of the water displaced. So if I want to figure out weight given mass, what formula to use? What formula has weight and mass in it?
Mass by gravity.
Right? So weight is equal to mass times gravity. So if I wanted to find for weight, it's going to be the mass. What's the mass?
1 kilogram,
What's the gravity?
10,
So the weight is going to be
10
10,
newtons.
10 newtons. Nice. So what we just now found for was what? What's that?
The weight of the object,
No. The weight of the object is 78 newtons. That's not what we find. Read that.
or the weight of the water displaced.
Right. When you use this formula, you're finding for the mass of fluid displaced. And to go from mass to weight, you multiply the mass by the gravity, and that would give you the weight of water displaced. So what you just now found for was the weight of water displaced. And we know according to Archimedes' principle, that's equal to the what? Tell me, Yvonne, according to Archimedes' principle, right? That would really be that would be equal to the what?
That will be the force exerted on the object.
Right. So that is the upthrust. Right. So that's the answer there. W is equal to 10 Newton. So the buoyant force, FB, would be equal to 10 newtons. That's the final answer. Right? Let me know if you understood everything I did there.
Yes,
Okay, nice. Okay, so Jadon, I need you to tell me if you understand everything there.
Yes.
Now, I
Yeah.
see you use a different formula. The formula you use is fine.
Yeah,
But
I was rewriting the I just rewrote it how you did it on the side. So
okay,
I was just like scrabble. I was honestly just scrabble.
now but that's fine. Right? Nice. So good job, Jadon. Right, Sheena, do you understand everything I did so far?
Yes, sir.
Yeah? Did you get through?
Yes, sir.
Yeah? Okay. Help me with part C. Right, I want you to help me with part C. What does part C say, Sheena?
Will the cube float or sink? Explain your answer clearly.
Now, we are directly talking about the three different conditions, right? Now, for something to float, the buoyant force must be equal to the weight. If something is sinking, the buoyant force is less than the weight. And if something is rising, the buoyant force is more than the weight. So let's compare. So tell me, Sheena, in this question, what is the weight of the metal cube?
75 newtons.
Right? Weight of cube is equal to 78 newtons. And what is the buoyant force?
10 newtons.
Wait, boy, I really going through it with a sore throat, boy. Good.
Yes, sir.
Right. Now, in this situation, will it sink or will it float?
It would sink
Right? It would sink. Why? It would sink because,
because the weight is greater than the buoyant
right.
force. Ultimate.
So you would say that FB is less than the weight, mg. Right? Great. And if any of you are confused, let me just draw a little diagram. Are you excited for Diwali?
Yes.
Yeah.
Oh, you know, it have a Diwali Math Vibes logo. Well, I think it's time to change it to that.
Yes, sir, just about.
Okay, I will change it. If I remember, I will change it after class. I will change all the logos to the Diwali logo. Yeah, I'm excited for Diwali too.
I'm really excited for the food.
That is a perfect answer. I can't blame you. And the barfi. God, hey, hey. I will barfi bad boy. All you like barfi?
Yes, sir. I like sweet rice more though.
No, this gone song real weird, eh? But you ever try sweet rice with roti? With paratha roti?
No.
Try it. That's just so good. Good. That's just real good. And even weirder, I just eat sweet rice with paratha roti. And no, it's boss up shot. It's boss up shot. And boss up shot is the one that's having prayers.
Yeah.
Yeah. Eat sweet rice with boss up shot. That tastes real good. And what I also do is I go eat the sweet rice with chana and boss up shot. Not real weird, but give it a try. It tastes so good.
Whoa, you have an interesting palate, so.
And no, it tastes good. It tastes good. It tastes good.
Hmm.
I could smell the silent judging. Like this man mad.
I ain't saying nothing.
Yeah, I can smell it. All right. So in this situation, the object is sinking. Why? Let me show you why. So Shayna, if I were to draw in the forces at play, I would draw the weight with a lesser length than the length of the upward force. No, what's saying?
Yes.
More. What's saying? Yeah, because in this situation,
The
isn't
weight is
it
more.
more? Yeah, this is 78 newtons, and the upward force is less. So do you understand that the downward forces would overpower the upward forces?
Yes, sir.
Jillian, can you see what I'm talking about? Watch. Watch clearly. Which force is dominating? Is it the upward force or the downward force?
Downward.
Right, so it will sink. I hope that's abundantly clear. All right, let's do part D. Part D talking about a spring balance. Let's read that one more time. So Shayna, actually no, Yvonne. Yvonne, read part D for me.
If a spring balance is used to support the cube while it is fully submerged, what reading will the balance show?
Do you know what a spring balance is?
Kinda, sir.
Okay, a spring balance is used to measure the weight. That's what spring balance is. Spring balance is used, not mass, eh? Weight. Weight. I sure if I show you what it is, all they gonna be like, oh yes, I know what that is, man. Let me show you. Any of all the parents is like mine chickens on him? Like to sell?
No, sir.
No? Okay, well I grew up with that, but this is our spring balance. Does this look familiar? Have you ever seen this before?
Yes, sir.
It's been in the market, man. I'll show you see this in the market. Jiran, you know what that is?
Yeah, you could also use
Yeah,
that to like weight
this
suitcases
one,
and stuff.
sir, this one look kinda new, I know.
Yeah,
When
this
I see him, kinda
Yeah,
old.
more metallic.
yeah, let me get the one that I'm more familiar with. Um This one. Everybody see this one. Wait there. Give me a second. This one.
Yes, sir.
This is one everybody would have see growing up in Trinidad. Did you never see this one before? Jadon, you ever see this one before?
Yes, sir.
Um, what about you, Shina? Can't hear Shina, but this is the one everybody will be accustomed with. So let me explain something. I'm gonna use the same diagram to send my point across. Guys, what is the net force on this? Jadon, if it's experiencing an upward force of 10 newtons, what is the downward force? Well, the downward force is 78, right? But if I already okay, for me to fully lift this thing up, I need to lift it up with an upward force of 78 newtons. You understand if that is the case, it will float, right?
Yes.
Okay. Out of that 78 newtons that I need to apply, how much is already there?
Um, it's 68.
No. Okay, look at the diagram, right? Because it's in water, it's
Yeah.
experiencing a upthrust. What is the
Mm-hmm.
upthrust it's experiencing?
The 10 newtons.
Right. If I want to fully lift it up though, I need to apply an upward force of 78 newtons. So out of that 78 newtons, what force is already there? Like pushing upwards.
The 10
The
newtons.
10. The 10. So if I want
Mm-hmm.
to lift this thing up now, what force will I need to apply to add to the 10?
It's 68 newtons.
Right. You understand it?
Yeah.
So watch. If I so when the spring balance measures the weight of this thing, it's gonna measure 68 newtons. And why is that? That is because it's already experiencing an upward force at 10 newtons. So the spring balance is gonna read 68 newtons. It's called a spring balance because it's used to like let me explain why, right? A spring doesn't a spring extend with a certain amount of force? Like, okay, if
Yeah.
you apply a four-star spring, wouldn't it extend?
Yeah.
Right. So how does this work, right? You have a spring on the inside. When you attach something to it, what would happen is it would cause the spring to extend. We did Hooke's law the other day. This is Hooke's law in action. And what it would do is they would calibrate it and measure a certain amount of, well, and this one is kilo and pounds, so it really should be newtons, right? So they will calibrate it and they will record and they will put specific labels. But the concept is there. So Jadon, how will this work again, right? You have a spring inside. When you attach something to the spring, what would happen to the spring?
No, that's not.
It would extend, right? It would extend, and that would cause this thing here to come down, and
Yes.
you sure you understand that?
Oh, yeah, yeah, I understand. I know. Yeah.
Okay, nice. Now, if I hook this thing up to the spring balance underwater, the spring balance is going to experience. Okay, let me try to explain this in the easiest way possible. Another way I could draw back this diagram is like this. And I think I'll learn how to see it like this. Have to. All right. So Jadon, 78 newtons here, right? The weight is 78 newtons. Yeah?
Yes, sir.
Okay. What's the upward force?
10 tons.
So I could draw the diagram like this too if I wanted. Okay, right? So tell me, if this is the case, then what is the apparent downward force?
68 newtons.
Right. So you understand the spring balance is going to read 68 newtons because it come like it's getting assistance. Understand?
Yeah.
It's getting assistance from where?
The 10 newtons of the upthrust.
Right. And the upthrust is because you're submerging the cube in water, right? We fully understand it?
Yes, sir.
Yvonne, do you understand it?
Yes, sir.
So what weight will the spring balance read? Will it read 78 newtons, 10 newtons, or 68 newtons?
68.
Right. Why not 78? Tell me, why not 78? See if you can figure that out.
Because that's the entire weight of the downward force.
Okay, and because they put it in water.
It's gonna be lighter.
Yes, yes, it's gonna be lighter. That's because the water would give it a little what? It would give it a little what?
A little upward thrust.
A little upward thrust, right? A little push upwards. So that can cancel off with some of the downward force. So 78 minus 10 is 68. You understand it?
Yeah.
Right. So the answer for this one, 68 newtons. Right. Great. Guys, the denser the medium, would the upthrust be less or more? Jadon, if the medium is dense, is really, really dense, like, okay, let me get an example, right? What
The
about
upthrust would be less.
the upthrust would be a lot more? Think about it. Think about it, right? Air. Did you know that air is a fluid?
Not really, then, no doubt, but okay.
Yeah, air is a fluid, right? Air is
Yeah.
a fluid. Do you float in air?
No,
Do you think air is dense?
it is.
Yeah, do you think air is dense? Okay, compare air to a metal cube. Which one is denser?
Cube.
The metal cube, right? Air is not dense at all. Remember, density refers to the amount of mass in a volume. And air weighs practically nothing. Does
Yeah.
air have a mass? Ajian, you there?
Wait, you're not hearing me, sir?
I hearing you. Does air have a mass?
No, it doesn't.
It does, but it's just like basically nothing, right? So yeah, it's basically nothing. So you understand that air wouldn't be dense at all. All right. Ask that question. Would you float? Where would you float easier? In in um in a freshwater pool or in the ocean?
In the ocean.
Right. Why is that? Which one is denser? Salt water or fresh water?
Salt water.
Right. That's because in salt water you have a bunch of dissolved minerals like salt. That is add to the density. Right? Okay. Next one. Where would you float easier in? Salt water or in mud?
Mud,
Mud. Which one denser?
mud,
So if you're in a denser medium, will the upthrust be more or less?
less.
No. More. End
Because they're keeping
upthrust?
you up. Yeah, because they're
Yes.
keeping you upwards. Okay, okay.
Yes. Because they're keeping you upwards. That is exactly it. Right? You understand?
Yeah,
Well, why was saying less though? I'm curious.
I think I was like just double guessing.
Okay. Well, you had to say something that makes sense to you. All right? You had to say something that makes sense to you. So think about it. Where would you float easier in? Mud or fresh water?
Mud,
Mud, because mud is less dense or more dense?
mud is more dense.
More dense, right? So the upthrust would be greater because it's denser.
Yep.
Yes. Great. So that's it. It's already 11 o'clock, surprisingly. All right, because I wanted to do more today, but I'm happy that we take the time to do practice and address some concerns because I see that all still had trouble with Archimedes' principle and the calculations. Right? So next class, we're going to look at dynamics and energetics. That's what we're going to move on to next class. Right? You all okay with everything we did today?
Yes, sir.
Yes, sir.
Okay, good.
Okay.
Right? So I hope all you have a blessed day. Right? Later, everybody.
Yes, sir.
Later.
Later, sir.